Okay, I must apologise last time. I think possibly the time before I didn't zoom in the text, and as I'm recording at 4K, it might be a little small. Shout if there's any problems, and I can post-process the video and try and zoom in a bit. So last time we created the SAM sprite class, and we got all the data, and we wrote our grab sprite handler, which went through and pulled all the data out into a file. So now, while there's lots and lots of functionality we can continue to add, the next, probably most important command we can write before we can start using this actually in programs is this one, the output all ASM. So what we will do is we'll add a new class, and machine's running very slowly again. Not sure on Windows 11. Might just be I've got so much I'm running, but so we want a new handler, and again, should be used to this by all the other handlers. It's a command handler, and we're going to want a public override bool is valid. True. This actually is quickly write this one because this is very straightforward. Get number of arguments. If it's not equal to 1, because the only argument we've got at the moment is the file name we're saving. Anything else is invalid, and we need our override bool run. It's amazing when you're typing and talking and recording a video how many mistakes you make while typing. Okay, so this is obviously where we're going to output our data. So let's just write a line. We will add commands to be able to selectively output in case you want to. Can't think of a reason I would, because I tend to just write everything out to a single file, and if I'm using multiple files, it's a case of grab everything for that file, export, grab everything for the next file, export. But we can do bits and pieces. Because there's going to be various things that need to write to an assembler file, rather than just opening the file here, I'm going to create a little helper file called an ASM writer. As I've said at various points, it's worth keeping certain things, rather than putting the same bit of code in lots and lots of places. You can hide it in a class. It means if you ever want to change it, which we're probably going to want to change a lot of this at some point, you only have to change things in one place. So again, we'll come back here and create our ASM writer class. Now this is just first thing I'm doing. Oops, it's because I haven't got a function called that yet. We're going to need a stream writer to actually write out the information. It's just basic text writing. We're going to need a close function, and we're going to need a open function. Close function is just a simple, if the writer is not equal to null. Really hard to type. Sorry, it's not equal to null, then I don't even think we need to call close explicit. I think it's called when you set to null anyway, but we'll be nice. Okay. So we want to create a new stream writer, and it's going to be a file stream. We're not. For those who aren't familiar with streams in C++, C#, it's the stream writer means we're writing to is the class for writing to stream, but we have to say what type of stream. In this case, it's a file stream. It could very well be like an HTTP web stream, a memory stream. You can actually change what sort of stream. Like I say, it's similar principle to why I split things into files. It means we can change where we're writing it to or reading from. We're just changing one little bit, not having to go and update everything. So here we go. Fail to create file. File name. Let's just, for completeness, we can tell it why. Oh dear. And return false. Okay. Now, what this class will have is various functions to write to an assembler file. It's not just going to be write string, because at some point we might want to write different sort of assembler files. I mean, this is just for SAMKP, but as well as I'll use one particular assembler, there's various assemblers you can use, and sometimes they have different formats. Comment. So I'm going to. So one of the main things we're going to want to do is be able to write a comment. I'm going to make it write a comment at the start of each file, just so we know it was automatically generated. So, automatically generated file, please do not edit. Obviously, unless you really know what you're doing and why you're doing it, you wouldn't want to edit we'll have a right blank line. You wouldn't want to edit it by hand, because as soon as you next built, you're going to find that you've overwritten it. So let's add that command. So just passing in a string. We can do check this writer's not null, and this is just literally right line. Now I could have added that onto the string. I could just do that, but what I'm going to do for now, comment char. I could put it as a. Let's put a few up here for now. We could put these in options. I probably will move into an options class, so we can actually have script functions to set these. But these are so we can change the format. So I'm going to put a string rather than a char, because just in case anything needs more than one. If I put a char, I can use single character, because some assemblers might want the double slash. While we're up here, let's put a few others that we're going to probably want. String label terminator. So all my labels are terminated with a colon. I'm going to have some EQU defines, which is EQU on the assembler I'm using. We're going to want some data string. Mine's DB, but I know some use DEFB. Just to be awkward, well, no, actually, because it makes it easier for reading, I'm going to write all of my values out in hex, so I need to prefix them as OX. Again, some use the ampersand, but let's say you can set these in the code specifically for what you want, but later so we will add some commands to set these things. What else? Anything else? Text column. So these last ones are data bytes per column, per line, sorry, is just when you're writing a large block of data, this is how many it will write on one line before it goes on to the next line. Doesn't need to be an option, but because I was adding the rest, I thought we would. Just shows you a few more options you can do, a few different things you can do. Text column, I'm a bit anal when it comes to assembler files. I like to have everything lined up neatly, so that's the column that all like the DB and EQU statements will be on. Do we need anything else? No, that should be enough. So down here, you see we've got the comment, we've got a right blank line. That's all there is to that one. Right. We can work out what other functions we're going to want as we're going. So if we go back to our output all handler, right, we need to open the file. Open a string. So it didn't open, that's fine, and at the end we're going to want to close it. Oh, I forgot that. Oh no, nearly forgot to put in output all ASM. Right. That was just warning me because I haven't used them. It's fine for now. I'll use them at some point, otherwise I'll delete them. So there we go. Let's see if I bring this up to the window so you can see. Ground palettes, loading images, output all is now being handled. And you'll see we generated presto. So we're generating our file. Okay. I tend to, we could just write the data. I'm going to split this into a couple of functions. Write some header information. I'm going to put it into a function just because it makes it easier. And then we're going to want to write the actual data. Especially in assembler, we're going to probably want to write a bit of information out, just so we've got some information on like sizes, numbers, anything that we're storing about the sprites and the palettes and other things that we might grab later. It means you can just write a list of EQUs, so you don't have to remember them. One thing we're not doing with our sprites that we're grabbing at the moment is we are not storing the width and height with the sprite data, which is something we probably could do. But at the moment what I'm going to do is I'm going to write that out as an EQU. Okay. Return true. So this is our write header information. And this is going to be our write the data. Okay. Now we want to write out all the sprite header information. To do this, we need to get the information. Now we could just return the dictionary that we stored back in our export data. We could just provide a list of all of the palettes and the sprites, but then we lose the names of them. So what I'm going to do instead, probably the easiest thing, because we've got our functions to get everything by name, and we're going to want the name. What we're going to do is return an array of all the names. The other good thing of doing this is it's quite straightforward, because we just go sprite.keys.toArray, and there we go. That will generate us an array of all the names, and we'll do the same for get palette names, and then we just use the functions we got above. Palettes keys to array. Okay. So now here we want to write out. First, need to get let's get the sprite names equals edd. Oh, why have I called it db? Because I was talking about data at the time. Get sprite names, and then we can run through all these. Okay. We got to get sprite function. Must have something to get the sprite by name. Has palette, get palette, get sprite. Yeah, we have. Where's that moaning? Oh, made them private. I don't want them private. We're not in public. Did I do the same with get palette? Yes, I did. Okay. So we've got the sprite. If sprite is not equal to null, which we know it won't be because we've got the list, but we need to check. Let's write some basic information. So we can go writer dot write define. I'm going to prefix all my sprites with SPR. That's the name, and this I'm going to write out the width. I'm going to write out the height. I'm going to write out the data size as well. Now, I don't think we've got a way of getting the data size. So we'll add that to start with. Public int get data size. Return from that. Just count the bytes. Okay. Now we need to add this function into our writer. So this one's a little bit more tricky. We want a string which is a name, and we want int which is the value. The reason this is a little more tricky is we might have spaces in our names. So first, if writer is not equal to null, technically we just want label terminator on the end, but I'm going to have a function. There's lots of characters you can't use in string names and things like this, so I'll make it public in case anything else needs it. We'll have a function called makeValid, which will take in a name and just play around with it, getting rid of anything that we don't need. So let's create output, return the output. So first things first, let's just check we've got a string, otherwise we'll just return what we had. needs a letter at the start, just in case you decide to call it 1 something. Let's check whether if the name hasn't got a letter at the start, what I'm going to do is add an underscore. And similar, we need to replace any space characters, because you can't have a space in the name. So we'll change them to an underscore as well. That's probably enough for now. I'm sure there'll be more, like we should check you haven't put any like ampersands or asterisks and any sort of special characters in, but that should do us for now. Now this way it gets a little fun, because I want to make it ideally so everything's lined up. If we don't do that to start with, actually, I'll show you why I do it. So now we've got this, we can write out the full name. We can stick like a couple of tabs in, and then we can put our EQU string, and then another tab, and then the value. So full label. And that's we're not using this. Fine. So if we run it again and then look at our sprite.s, oh, did we get an error? Failed to run. Oh. So let's have a look in output all handler. Let's no. We're saying if it's fine, send an error. Oh, we're not closing the file if we go into any of the errors. Probably should. That's why it didn't have anything in it that had written to that point. Not the easiest way of doing it, repeating the close all those times, but it's fine. It's because this file's always here, so this doesn't actually get cleared. It should get cleared. Anyway, I'll check into that later. So as you see here, we've written out the widths and heights and data sizes of all the sprites we've grabbed, but they're all over the place, and it annoys me. But what we can do, we can try and get them to line up. So we can go space count equal now, just in case the string is longer than our column, we'd end up with a negative value, and that doesn't really work. So make sure we put at least, I mean, you put 0, you could put, I suppose actually make more sense to put at least 1 space in. And so we want our text column minus the full label length. And then this bit here, where we just stuck in 2 tabs, we need to put we need to create a number of spaces. So what we can do here is we can do string spaces equals new string, our space character, and how many we want, and that will create a string with that number of spaces. Run that again. And there we go, they all nicely line up. Isn't that much nicer to look at? What will actually probably be even nicer. It's ridiculous in some ways, because these are generated files that you don't even need to look at, and it compiled just fine the other way around, but as I said, I'm a bit anal. There we go. Okay, so we've done those ones. we can now do pretty much the same again to write out some header information about the palettes. So we want to get the palette names. This time we're going to get this palette. Get the palette by the name. Check we've got the palette. This one, we've not got as much to write out about the palettes. Palette score. In fact, probably the only thing we've got is length. We'll just write out how many entries there are. This should pretty much be it. There we go. Palette main length, 16. Can't think how we grabbed it. Oh, we just grab it at the... I just thought there would have been less than 16. We'll see what data we get. I was only expecting a few colours because there's only a few colours in the test image. Right, so onwards. In some ways this still feels slightly wrong, the way we're doing this, because it'd be nice if the sprites and the palettes wrote their own data out. Might change it later, but as I say, let's just get it working for now. So we want to write the data out. The only reason I say that is because if we now, in our script, we've got further down, we've got functions to output single frames, whereas we'd have to duplicate this code again in a different handler, and so if we want to write out different information, but that's fine. We can create helper functions or something at a later date. For now, we'll just get it so it's exporting. So again, we're going to run through to write out the date. We're going to run through. But the only thing we want to do is write out the data. We need to get the data. Let's have, I'm going to call it serialize. We need to be able to pass out the data. I'll call it serialize. That will basically serialize any of the information. In this case, it's just the data. It will serialize any of the data out into a byte array, which is nice and easy for this one. And then we want to have this function in called data. And so first things we need to do is if writer is not equal to null, let's create a new space string. This time this is just going to be our text column number. This is where we're going to put the DBs. Oh, we need to write a label out. So writer, write line, and again we'll make the name valid. We just need the label terminator. So all the data will be on the next line. So we want to run through all of the data bytes, and we're going to do 2 loops to pass this through. J is going to be the number of lines, and then we need to know how many bytes we're going to do this line. Obviously, most of them will be we want the minimum between where's the maximum? So this is how many bytes we've got left to do, and that's how many. So yeah, so we want if we've got too many bytes, we want to do them correct, and we just want to do up to data bytes per line. If we've got less than that, that's the number we need to do. So now we want to, each line is going to start with all the spaces we created, the data string, and a tab. Now we need to run through the I is less. Let's just do number of bytes. Add the byte. So we need to add this onto. So add the hex prefix. Now we want the byte of data, and I want to convert it to a string. That's the nice thing about doing it in C#. Presto, we've now got it in hex, in 2-byte format. And then it's not nice, but it's easy. We just want to add a comma if we're not the last byte. So if we're not the last byte, add a comma. And then, nearly forgot the important bit. To write that line. That should do that. So we go back to our output handler. Let's just comment out the palettes for the moment, just check it's working. Write data. Oh, plus. That's better. Ooh, out of range. I'm imagining it's this J plus I. What have we got wrong there? J minus I. Enter all the data, length on data bytes per line. We've got 101,421 bytes. Oh, no, it is min, isn't it? We do want the minimum. We've got 1,016, we want 16, not 1,000. Right. That looks good. And these ones where we've got mask data. It's all looking like we've got masks. That's looking good. So the data write is fine. So the last thing we need to do is just get it to output all the palettes. So again, we need to serialize the palette. So if we go to our SAM palette, let's go down the bottom and we don't have our data in such a nice format. We should change that really. When I wrote this class, we put an int of byte data and created it at 16 bytes. We could just use a list and push them on rather than storing both. I might change that in another next part, but for now, we can just create a byte array. So simply pull it out into a new array. It's not nice. Feels a bit hacky. But that should mean if we come here, we're expecting 16. Oh, I think I've remembered why. I was looking at 6. I was expecting, because if we look back at the image, there's only about 4 colours in it. So I couldn't work out why we had 16. We've got this 3F at the end here, which I imagine why is we grab main. Yeah, see here we're setting the 16th colour, the 15th, 0 to 15. So as far as it's concerned, it's now got a full colour palette. That's fine. Yeah, so as you can see with that, we're now exporting all the data, which should compile. The only thing I'm going to change, because a little bit anal, is I'm going to make that a capital. I might have to make a second column because DB only pushes out 1 with a tab, whereas this comes out quite a long way, so I might have to replace these with spaces as well to make them all line up. But it doesn't make any difference. But as I say, if I come in here and we go, let's say 8, and we run it again, hopefully what we'll find, see now it only outrights out 8 bytes. Makes your file bigger, but I find 16 is about sort of right for the screen size. Ideal. What I'll do next is I'll probably get this initial code up onto GitHub or something, so if anyone wants to grab it and have a play around. I'll quickly knock up a very simple SAM program to assemble with this data and print some things on screen as well. Yeah, hopefully that's been useful.